Hi friends, today I am giving a lecture on insert operation on a red block tree. How we are performing the insert operation on a red block tree that can be discussed in this video. Okay, first of all, we are already know that insert operation on a binary search tree. Okay, the insert operation on a red block tree is the same as insert operation on a binary search tree. Okay, suppose we want to insert a node on a binary search tree. First, that node value is compared with the root node. If it is less than the root node, that can be inserted into the left subtree. If it is greater than the root node, the node can be inserted in the right hand side. Okay, so the same rule is also applied in the red block tree. Okay, but in the red block tree, every node is either red or black. That is the difference. Okay, next, to perform the insert operation, so these are the rules we have to follow. Okay, where these rules are used, that can be discussed in this example. Whenever that rule is occurred, I am explaining that rule. After that, you can easily understand. Okay, so first one is insert these elements into the red block tree. Okay, first one is insert 25. Okay, so initially, so the red block tree is empty. That means there are no nodes in the red block tree. Okay, whatever the node that is inserted into the red block tree, that node is a root node, because before that one any nodes are not inserted into the red block tree. Okay, next one. Any node is inserted into the red block tree, that node can be treated as a red node and it is denoted by X. Okay, first red block tree is empty. Okay, whatever the node that is inserted into the red block tree, that node is a root node, that is a red node, and it can be denoted by X. Okay, next. Now we go for condition. This is the red block tree or not. Okay, here we check the condition. The newly inserted node. The newly inserted node is 25. This can be denoted as X. It does not have parent and it does not have grandparent. It does not have uncle. Okay, next. If X and Px are red, here X is there, but Px is not there. Px is nothing but parent. Okay, OR root is red. Yes, this condition is true. Root is red. This node is already a root node. Root is red. Call any of the following cases. First, we have to observe case A. If the root node is red, this is the root node, this root node is red, then color of root node is changed to black. Okay, so this is the root node, color of this node is red, then it can be changed to black. This is X. This is also a root node. Why? Because in the previous video we are already say that the root of red block tree is black. Okay, next. So now this condition is satisfied. Now it becomes a red block tree. Okay, next one. Next one is insert 14. Insert 14. Okay, so before insert 14, the red block tree contains only one node, that is 25. This is a root node. Okay, now 14 is compared with the root node. It is less than the root node 25. Okay, so that it can be put in left hand side. This node can be treated as X. Okay, whatever the node that is inserted into the red block tree, that node is a red node, then it can be denoted by X. Okay, now X contains a parent. X contains a 14 has parent, that is 25. Now this can be treated as Px. Okay, 14 parent is 25, that is Px. Okay, now this is a red block tree or not? Okay, now the newly inserted node or current node is named as X. The newly inserted node is 14, that can be denoted by X, and its parent 14 parent is 25, it can be denoted by Px. Okay, and it does not contain any uncle, that is Y. Leave it. Next, if X and Px are red, false. Root is red, false. Okay, then call any of the following procedure. Okay, both are false, then there is no going of case A, case B, case C. So our tree is a red block tree. Okay, now insert 45. So insert 45. Okay, now 45 is compared with the root node. 45 is greater than 25. So now where we are inserting 45, 45 is greater than 25, so that 45 is inserted at the right hand side of 25. Okay, so it can be denoted by X. Okay, previously it is already 14 is there. Okay, now so here 25 is root node is 25, it is a black node, and 14 is red node, and 45 is red node. Okay, so 14 is less than 25, 45 is greater than 25. It satisfies the binary search property, and root node is black node. Okay, next one, newly inserted node is 45, it is red node. Okay, previously inserted node, that is 14, it is also a red node. Okay, next, here X and Px. So this is X and this is Px. X and Px are red color? No. 45 is red color, red node, and 25 is black node. This condition is false. Root is red. This condition is false. Both are false. Then there is no need of go to case A, case B, case C. Okay. Now this is correct. Up to now, this is the red block tree after inserting 3 nodes into the red block tree. Now we go for fourth node. Insert 51. Okay, so insert 51. 51 is compared with the root node 25. It is greater than 25. Go to the right subtree. Next node is 45. 45 is compared with the 51. It is also greater than. So then go to right hand side. Now 51 is inserted to the right of node 45. Okay, so the inserted node is a red node and it denoted by X, and it is denoted by X, and its parent is Px, and its grandparent is Gx. Okay, and sibling, parent's sibling is 14. So this can be denoted by Y. Sibling is nothing but grandparent son or daughter. Grandparent son or daughter. Parent's sibling means X parent is P of X. P of X and uncle are same at the same level. Okay, grandparent son and parent both are on at the same level. That can be denoted as sibling. Okay, X is currently inserted node. Okay, and its parent is Px and its sibling is 14, that is Y. Okay, parent's sibling is 14. It can also called as grandparent. X grandparent is Gx. Gx son is sibling. Okay, so this is a sibling, it can be denoted by Y. Okay, now this is a red block tree or not. Okay, now go to this condition. The newly inserted node is X, that is 51. Okay, its parent is PX and its grandparent is GX and its uncle is nothing but parent's sibling or grandparent son. So that is called as uncle. Uncle can be denoted by Y. Okay, now if X and PX are red, as X and PX are red, or our root is red. Okay, root is not a red. Here this condition is true. If X and PX are red, two consecutive nodes are red nodes, then we have to follow this case. Okay, what is this case? Okay, if the root node is red, root node is not red, then there is no need to case A. Next one, case B, right uncle condition. Here uncle is white, it is a red node. Okay, uncle is red node, then we have to use these three conditions. First one is locate uncle as Y. So this is uncle, it can be denoted by Y. Make the color change. Make the color change. What is color change? Color change means, so these are, okay, grandparent as red. Here the grandparent is 25, X grandparent is 25. Then change the color of grandparent, that is grandparent color is changed from black to red. Next one, uncle and parent as black. Uncle is 14. Okay, uncle is 14 and parent is 45. Okay, per 51. So this is 51. These are the changes that can be done. So this is X, this is PX, and this is Y, and this is GX. Okay. So here two consecutive nodes have red color. Then we have to use the following cases. Case A, root node is red node. Root node is not a red node. Then case A is false. Then go to case B. Case B is right uncle condition. Here uncle is nothing but parent's sibling or grandparent son. Okay. So here this is uncle. Uncle color is red. So red uncle condition. This condition is satisfied. Now we have to use these three steps. First one is locate uncle as Y. Uncle can be denoted by Y. Next, make the color change. Here color change means these are the two steps we have to follow. Grandparent as red. So X grandparent is GX. It can be changed to red node. Next, uncle and parent as black. Here uncle is 14. So 14 red node to black node change. And here X parent is P of X. Okay, now parent color, parent node is red node. It can be changed to black node. Okay, next 51 X, that is no change. Now this is a red block tree or not. Okay, so first condition. So if X and PX are red, okay, X and PX are red, this condition is false, or root is red, as root node is a red node. Okay, one is false and another one is true. Total is true. Call any of the following cases. Case A, if root node is red, color of root node is changed to black node. Okay, now it can be changed to color of root node is black node. So that is color of root node can be changed to black node, and the remaining nodes there is no change. So this is left hand side 14 and right hand side 45 and 45 right hand side is 51. So this is X, this is PX, and this is GX, and this is uncle is Y. So these are the changes that can be done that is case B. Here, whenever red uncle condition is there, locate, this is the red uncle. So this is X, its parent is P of X, its grandparent is G of X, and its sibling is Y. Sibling is can be denoted as uncle. Red uncle condition is occurred. Locate uncle as Y. Next, make the color change. Make the color change means grandparent as red. Here grandparent is black, that can be changed to a red color. Uncle and parent as black. Here uncle is red, and that can be changed to black. Here X parent is PX. PX is red color and PX can be changed to black, and 51 is no change. Okay. Now here we know that root node is black node, but here root node is red node. Now check this condition, root is red, call any of the following cases. Okay, if root node is red, color of root node is changed to black. So color of root node can be changed to black node, and remaining there are no changes. Okay, now we have to check this is a red block tree or not. Root node is black. Any two consecutive nodes are red nodes? No. Here 25 is black, 45 is black, and 51 is red. Here both are black. Any two consecutive are red nodes, then it violates the red block property. Okay. Now up to now, after inserting 4 elements, this is the red block tree. Now we go for insert 55. So before inserting 55, this is the obtained red block tree. Now we are inserting 55. Now 55 is compared with root node 25. It is greater than 25. So then we go to the right hand side. Here 45 is there. 45 is compared with 55. It is greater. Go to the right hand side. 51 is there. 51 is compared with the 55. So 55 is greater. Then go to the right hand side. Then we have to insert 55. Okay. This node is X and its parent is PX and its grandparent is GX. Okay. Now this is the red block tree or not? Okay. So here X and PX are red. Before that, the newly inserted node is X and its parent is PX and its grandparent is GX. Grandparent is son. It is not there. It is sibling. Here sibling or uncle. It is not there. Okay. Or PX sibling. It is not there. Okay. Next. If X and PX are red. Yes. X and PX are red. Then root is red. Root is not red. This is true and this is false. Total is true. Then call any of the following cases. Case A, it is not suitable because root node is red. No, root node is black. Then case B, red uncle condition. Here uncle is not there. Grandparent is son and parents sibling. It is an empty node. It is also false. Then go to case C. Case C is no uncle or black uncle condition. Here no uncle, parents sibling is not there. This is an empty node. So that this condition is satisfied. That is case C. Case C low, then which are used these cases? Either case 1 are used or case 2 is used. First one. Case 1 is used X, PX, GX on same side. X, PX, GX all are on the same side. Then we have to use case C, case 1. First one is change the color. Okay. Change the color means what color we have to change? What color we have to change? Color change means grandparent as red, uncle and parent as black. Okay. Grandparent is red. So that means grandparent is red means grandparent is X grandparent is 25. So that it is red. Okay. And uncle and parent as black. Here uncle is not there. Parent is there. Parent is black. Parent is black. Okay. and the remaining nodes there are no change. So that is 25, and this is 14, and this is 45, and this 45, 51, and it is also 55. 55. This is x, and this is px, and this is gx. Okay, now x, px, gx on the same side, we have to follow these conditions. Change color. Change color means grandparent as red. Here grandparent is previously black. It can be changed to red. Next one, uncle and parent as black. Here parent is 51. It can be changed to black. Okay, 55, no change. After performing the change color, opposite side rotation. Opposite side rotation means this is right, and this is also right. Right rotation. Then goes to left. So then we have to move this one. Then we are getting 25. Left hand side is 14. Whenever we are rotating the left hand side, then we are getting, so this is 51, and 45 is left hand side, and 55 is right hand side. Okay, so this is x, and now this is px, and this is gx. Okay, now it satisfies the binary search tree property or red block tree property. So 25 less than 14 is less than 25, it is left hand side. 51 is greater than 25, right hand side. 45 is less than 51, left hand side. 51 is greater than 55 is greater than 51. So it is right hand side. Now it is a red block tree or not. First one, root node is black. Yes, root node is black. Next one, any two consecutive red nodes are there. Now consider this path, there are no consecutive red nodes. They consider this path, there are no consecutive red nodes. So consider this path, there are no consecutive red nodes. So now this is the red block tree up to 55. Okay, now we go for 40. Now next is 40. Okay, where we are inserting 40. 25 is compared with 40. So 40 is greater than 25. Go to the right hand side. 51 is compared with 40. Okay, so 40 is greater than 40 is less than 51. Okay, then go to left hand side. Left hand side 45 is there. 40 is compared with 45. 40 is less than 45. So then go to the left hand side. Okay, left hand side, the newly inserted node is 40. Then it can be denoted by x, and its parent is px, and its grandparent is gx. Grandparent son and parent's sibling is uncle. Uncle is denoted by y. Okay, now this is a red block tree or not. Okay, so first one, the newly inserted node is x, and its parent is px, and its grandparent is gx, and its uncle is parent's sibling or grandparent's son. Yes, this can be denoted by y. Next, now go for if x and px are red. Yes, x and px are red. Then among these three cases, any case is true, that case is to be followed. Okay, if root node is red, root node is black, then case A is false. Then go for case B, red uncle condition. Red uncle means that is by parent's sibling or grandparent's son. So this is a red uncle condition. This condition is satisfied. Now we have to follow these three conditions. Locate uncle as y. Yes, this is uncle. It can be denoted as y. Next, make the color change. Make the color change means it can be changed to grandparent as red. Here grandparent is 51, so that can be changed as red. 51 can be changed as red. Next one, uncle and parent as black. Here uncle is 55 and parent of x is that is 45. Parent of x is 45. That is 45 is black. And uncle 55 is also black. Okay, and the remaining nodes, no, there is no change. This is a 25 and this is a 14. So there is no change. And 40 is a red color. Okay. So now this is x, this is px, this is gx, and its uncle is y. Okay. Now it is a red block tree or not? Okay. So root node is black node. Yes. Any two consecutive red nodes are there? So there are no two consecutive red nodes in that path. There are no two consecutive red nodes in that path. There are no consecutive nodes in that path. So this is a red block tree. Okay. Now we go for insert 32. So now insert 32. Up to now this is the tree. Now insert 32. Where we are inserting 32. So first 32 is compared with 25. 32 is greater than 25. So then go to the right hand side. So 32 is compared with the 51. So 32 is less than 51. So then go to the left hand side. 32 is compared with the 45. It is less than 45. Go to the left hand side. So 32 is compared with the 40. So it is less than 40. So that go to the left hand side and inserted 32. And inserted 32. Now this node is x. Newly inserted node is x and its parent is px and its grandparent is gx. Okay. Now, so this is a red block tree or not? This is a red block tree or not? Now, the newly inserted node is x, that is 32, and its parent is px, that is 40, and its grandparent is gx, and it's 45. Okay. Now, and its uncle. So, parent's sibling or grandparent's daughter. Here there is no uncle. Okay. So, next. If x and px are red, here x and px are red. Okay. So our root node is red. Root node is not red. This is false. This is true. Total is true. Then which condition is followed? So case A is not followed because root node is not a red node. Then go for case B. Red uncle condition. Here uncle is not there. So then go to case C. No uncle or black uncle condition. Here this is true. No uncle. Here parent's sibling is not there. Grandparent's son, that is also sibling, is not there. Okay. Now case 1. Go for this condition is true. Then go for case 1. X, px, gx on the same side. This is x. This is px. This is gx. All are on the left hand side. Okay. On the same side. Then use this condition. Case C, case 1 condition is applied. First one is change color. Okay, change color means grandparent as red, then go for this one. Okay, grandparent as red and uncle and parent as black. Here grandparent is 45. So 45 is red. Okay, next uncle and parent as black. Uncle is not there. Parent, ex parent is 40. 40 is black. Okay. Next, the remaining nodes does not change. So this is 25. and this is a 14. Okay, so this is 51, 51, 51 left hand side, that is 45, 45 left hand side 40, and 40 left hand side, that is 32. 32. Okay, and 51 right hand side is 55. Okay, now this is a red block tree or not. First, root node is a black node. First condition is true. Any two consecutive nodes are red nodes as 51 and 45, or two consecutive red nodes are there. Okay, so here change the color, we have to change that color. Then opposite side rotation. Okay, so these are on the same these are on the same side. X, px, gx are on the same side. Okay, we have to use this condition case C, case 1. Change the color. Grandparent as red, this grandparent as red, uncle and parent as black. Here uncle is not there, parent can be changed to black, and this is X. Okay, now this is X, and this is px, and this is gx. Now we have to perform the opposite side rotation. Opposite side rotation means, so here this is a left rotation. This is already, this is left, then go to right rotation. Okay, after performing the right rotation, okay, here after performing the right rotation, so this tree we are getting, so this is 25 and this is 14. Next 51, that is red,